Welcome everyone. So this is the very first Cursor community event in Macau. So I'm John. I'm a data analyst, developer, also chairman of Macau Startup Club. I'm currently working in Macau as well. So today I'm very happy to work together with Macau Data Lab as well. Some of our partners in this event, or some Macau Startup Club as well. So we organized this very first Macau Cursor community event. So Macau Startup Club do organize a lot of startup events, but it's not technical. The reason why we would like to bring Cursor to Macau is because we want some more technical events to be happening in Macau. So we got to fill this technical type of events. I know Macau Data Lab, you guys organize a lot of technical workshops, so this is a good thing. So we should work together and bring more of these technical events to Macau. So I'm so excited because we have developers, we have data analysts, we have IT experts, we also have startup people coming to this event. This is the first Cursor event that we organize. Upcoming one will have some more technical workshops and also hackathons is upcoming. I already talked with people in Cursor team. They will help us to arrange some resources. So originally, they will assign someone to talk with us today as well, but because of the time zone issue, they didn't really were here to talk with everyone. But they do prepare a video about the introduction about Cursor and to say hi to everyone. So today, Cafe Cursor, the format is quite informal. It's mainly for people together, and you guys can sit here to do your own coding and for chatting with each other. It's also like sharing of your own projects. So feel free. If you haven't ordered your coffee, just let our staff know. The Cafe Garage, the staff, each of us can order one coffee. So it's also sponsored by Cursor. So today's event, if you order food, it's on your own, but then for coffee, it's from Cursor. Yeah. So enjoy, and now maybe you can play the video from Cursor team. Yes. This one. Yes. Just wait a while. It's loading, it's loading. Yeah. I think we have to have a sound.
I think the volume. Cursor community event. Big shout out to John for everyone. This is Ben Lang from the Cursor team. I just want to say hi and say how excited we are about the first Cursor community event. And big shout out to John for setting this all up, and I hope you can support more in the future.
Yeah, I think that's all. No, all is loading.
Build each other.
Oh my god.
Wi-Fi.
So let us know. Try to hear your feedback.
Let's pause a while.
So don't ask for ID support.
ID support. ID support. We need ID support now.
I love the pet jokes.
Yeah. It's all up, and hope you can support more in the future. And just excited for you to hang out, build, meet each other. And if there's ever anything we can do, let us know. Try to hear your feedback, try to hear what we can do to improve Cursor, and look forward to supporting more in the future. So thanks so much for coming out. An amazing time. Hopefully see you at some point soon. Thanks a bunch.
So they actually record this for us because they cannot really attend in person. But I think in coming future, when the community grow bigger, we'll try to invite them. Yeah. Okay. So originally we want to do a quick introduction of Cursor, but then I think all of us are too technical here, so we can just skip this introduction. And I heard some of us would like to do a demo, right? On your own project. Sharing? Do you want to do it now, Daniel?
We can just,
informally?
So at the end, we can show what we do now.
Okay, we can do it later. So I think today just enjoy the atmosphere, talk with the like-minded people, and then let's hack together, and also have to get back to work. Thank you.
But I think everyone should download the cursor.
In case you guys want cursor credits, leave me comments. I'll try to use our comment to ask for credits because they do have options for me to apply for credits for all of us in community. Yeah. One more thing. Please do join our WeChat group. Just trying to build a community. Just try to join our WeChat group. Yeah, thank you. Should we take a photo together?
Everyone, Macau Data Lab here. And next session from Victor, he will be showing us recursive language model, how you turn the, how you optimize the lengthy context with this kind of new infrastructure. Okay, let's get right into it. Let's welcome Victor.
So before I get started, this project was inspired by a research paper published by this dude here, and he got a whole blog post, which is basically what I just did. And I really just throw his blog post into it, and then you use a Hugging Face library to recreate that. Really, the premise for the paper that they were talking about is how do you resolve context frauds? And the paper was published at the end of last year before the crazy agent shit that happens. And really, the paper actually just tackled the same stuff that everyone is tackling now, which is can you offload context from the context window so that the LLM doesn't have to solve all the problem in the latent space. So this is a blog post. If you guys want to go look at it, just find this guy or just search recursive language model and you should be able to find it.
Can you send it to the group as well?
Oh yeah, sure. I'll probably post it later. And he also have his own implementation, but to challenge myself, or not really challenge myself, to challenge ChatGPT. I have ChatGPT to write me basically a separate implementation using the Hugging Face small agent library. So why do this? As I said before, agent kind of forget stuff when the context get long enough. And the reason for that is that because signal in a specific information get really sparse when you have a lot of them going on, and the attention mechanism might not be able to kind of solve the specific signal that you're looking for in it. And they were like, well, instead of having, the LLM itself to find it within the LLM process, either through optimization of the architecture, why don't you rely on this problem-solving ability that emerged from LLM? And they were like, well, if I can just throw everything, how would a human do it if human want to read a large document? What it does, instead of reading it, what some of us would do will probably open a Python environment, have Python to write some stupid regex code to figure out stuff for me. So that was the premise for that. And this is basically saying the same thing as what happened today. Well, not what happened today. What happened when the guy wrote a paper is that you throw everything into it and ask a question, and you hope, finger crossed, that ChatGPT is going to figure it out. Or you can do some RAG process where you hard code some sort of search patterns or vector store. That was the big fuss back then. Have some way to find information and then fit it into the context the LLM and then hope that it's the right stuff. Yeah, so the analogy is like, I imagine you need to read 200-page document and all you can do is like read it at once. Why don't you have notes and pens and paper? That's kind of what it is. Yeah, and then the guy talked about like what would he do instead? Like, he would like, skim the document, like maybe look at all the headlines, break it down into session. Maybe he would like write down like what each session does, and then like he'll actually go have his own process and like go actually detail read a specific session, and then like, through all that problem solving, like you'll come to the right answer. So how does RLM, like the whole concept actually works? So in terms of like code implementation, you would have like a front, just like an LLM.run or whatever that you pass it into. So you will have like, your task, and then, the actual context that you need, the information, you pass it into the function. And then underneath the function, it actually, instead of passing the whole thing into the inference endpoints, you create a Python environment and then store the document as a variable in the Python environment. And the LLM would actually look at it and then, write its own Python code. Or part of the recursiveness of this is that you actually expose a LLM inference or a agent inference as a Python tools, so that the model itself can actually write the code, and the code itself will call the model again. The whole process kind of reruns. Obviously, you got to have to keep track on like what part of the process you are. So in my implementation, I build like a node trees to kind of keep track on like how deep you are in it, and you can set a hard limit of how deep you can call a recursive agent, and then kind of just let it rip a little bit, as the kids will call it this day. And then once the model thing is satisfied, you've done all the stuff, it will spit out the result. The environment so there's actually a better diagram that this guy has written. So he has his TLDR, da-di-da. That is his diagram. Maybe it's a bit hard to see. Let's see if I can zoom in. There you go. So you have like your query, your context. You throw the query into the language model, but the context actually lives in what I call a REPL environment. It stands for read, execute, print, loop. So standard Python stuff. That's kind of how you do Jupyter Notebook as well. You've got a bunch of like cells. You run it, you print the results, and you do it again. Yeah, and then it has like kind of recursiveness to it. Anyway, so I mean, and this is kind of like a hypothetical approach that the agent would take. So in a traditional approach, you might just like, write, you just call the model, say model inference, here's like a 50-page report, blast, summarize it, and then you finger cross. You can pretty much do the same thing if with how the guy implemented. He said you should just put out like a front end, call an RLM, you give it a query, and you actually pass the your 50-page summary instead of a strings. You pass it as like a variable, and then let the process kind of handle it. And you can actually write in the prompt. You can actually instruct it. So the guy I looked through the prompt that he has. Just having an agent set up doesn't really work. You actually need to instruct how the agent do it. So he gave a few examples of what the problem-solving process the agent can actually take. So you can do schemes. So ask it to just look at the first 500 characters. You can do a search, so you can get the agent to write a regex function to extract relevant information. You can do split, so ask the agent to split this long string into multiple different strings, and at the end a summarization. So that's pretty straightforward. And from the research guide that he did, he had, so the kind of like the star diagram that he has was that he has a 10 million context that he need to solve, and using normal method, like even the top model, like use ChatGPT 5, it would not hit like even 10% of what he want to recall. Whereas using his method, he's getting 100%, and it's 100 million context windows. Where I remember GPT-5 only had 128K context window at the time that was released. So, you know, that's obviously outside of the scope of what the model can handle. And they even has, so some of the finding he has is that, like, you know, it can actually find very specific things, and also things that are kind of require problem solving. So for example, it's like he has text that say you actually need to string 5 different information from different part of the document. And he showed that his method can do it other than, and he also compare, like, you know, standard kind of, from what I remember, he also compared to like factor search and all the stuff like that. And obviously factor search would have its own limitation because you actually need to see, like, oh, you know, the strings that you're searching has to have some sort of like, what's the word I'm looking for? Meaning, like, search, yeah, there's some sort of like similarity, like factor similarity to like the chunk that you were splitting. And he's saying that, like, this is a more reliable method, which makes sense because, like, you know, he really just like took at what a human would do and go like, okay, I'm going to give all the tools I need for an LLM to achieve that. So, and I do have like a notebook that recreate that. I'm not going to run it because it takes a while. And all of this, I also, if you look at my GitHub, it actually has all the implementation, and it relies on you having some sort of endpoint. So I have my own computer at home that can run Qwen 3.5.
Also, it's your local LLM.
Yeah, so I, like, when I run this result, this was all local. There was no like external endpoint for that. But at the same time, when I was testing this, I didn't have a document that is 10 million context windows. I wouldn't know where to like find document and when to find tasks that actually appropriately test the ability. So I have Claude to made up some large documents and then made up some, like, you know, questions that require an LM to solve it. And in fact, you actually don't need, with the examples I created, you don't need this method. Like Qwen 3.5 was perfectly able to like just fit everything in it and able to resolve that, which is incredible because it's like, you know, it's like the latest small model you can run on local, and it's already fitting like model that was, you know, supposed to be state of the art like 18 months ago. But, you know, the real kind of the problem that it's trying to tackle is like ultra long context windows that not even the top model can resolve. Like, I think Claude like Opus 4.7 is 2 million they're claiming, but I don't think I'm pretty sure after like 500K, like the ability degrade quite significantly. I can like show the notebook. Given that I wasn't using cursor at the time, I wouldn't show any non-cursor product on here. but the notebook is self-explanatory, so it's that's like a good medium to showcase. Yeah, exactly. You can just, everyone can just copy, you know, fetch this repo and then run it on their own. So, so this is kind of just showcasing you how to use it. And this is some of the example code that the model actually runs. I also have, so for this whole thing, I actually also wrote a helper that able to export all the kind of model output into a HTML, so you can actually examine what the model is doing, because all the traces, given I was running my own endpoint, I was able to fetch kind of like all the output and input of the models. This was in the summary that I was talking about, and I can talk a bit about like the code I was running. So the main kind of like object you need to call is just RLM. You can create an RLM object, and it's dot completions, and you give it, you know, the task that you want, and then the context as a separate stuff. and it should kind of just work like a normal LM endpoint the way that like this is created. What's doing underneath is that it actually stores the context as like a separate variable, and it called the Hugging Face agent library. So the small agent library is a library that Hugging Face has created. It really just have two agents. It has a code agent which creates its own kind of like Python sandbox environment, which is great because I don't have to rewrite that implementation. I wouldn't know how to do it. It also has like a two agent implementation. If you guys have used MinMax agent library, I'm pretty sure MinMax was just copying what this is doing because the code looks exactly the same. So if you guys are like want to like learn how to use like kind of like create your small agent and stuff, so this is a really good start, the Hugging Face small agent library. Underneath what this is doing is just like there's two separate core again. There's a LM core as a tool that I gave it, which is just simply calling the LM. There's no agent involved. So maybe once it gets down to like the most bottom layer of the node, you know, you can't really recall an agent again. It will just simply call an LM to solve that problem. It's kind of like a tree structure, and then like the end, like the last node would just be a simple LM call. And if it's not, you can still call RM call again, which is the same thing as doing here, which is just recalling the same kind of like object here, and it'll spawn more stuff. And here's the configuration. As you can see, I was just using my own like local host service. I think this test case I was using Quant 3.5 35B. It was like a decent enough model you can run in.
Oh my god, you're running 35B model in your local.
So if you use
So you have a pretty.
So I have
But he has a combination.
Yeah, so full disclosure, I was using, like, I have only one GPU, and it was like a Taobao modified GPU with like 22 gigabytes. But if you don't have, I think Quant 3.5 can actually run at 8 gig GPUs if you use Llama C++.
IQ4, I think, is divided by 4, right?
It's a dynamic, so this is a really, so, okay, that's another rabbit hole I can go down. So I was using Unsloth, so they're a really good resource with fine tuning. They actually have a new kind of like project that came out that is like a GUI for both inference and fine tune, and also creating like fine tune synthetic data sets. So this is kind of like do it all, but they started us doing like quantization of models. So they already have the latest 3.6, so you can have a look. They use their own kind of dynamic method.
The quantization is 4 bit.
Yeah, so they have their own quantized method, and you can see that like, you know, the way that they quantize it get down to like a various size. So the smallest they can
our
do.
one is using the full one.
Yeah, the full one is.
Don't worry.
It's if you're rich, sure.
No, not us.
Yeah.
Apple is rich.
Yeah.
Apple is rich, not us.
But so the inference library I was using was actually Llama C++. So they have a method where they can offload specific portion of the weights to CPU, and because this Quant 3.5, this specific version that they have, is a mixture of experts where only a specific model is actually activated at a certain given time. Llama C++ actually already have a built-in way to have all the like attentions lives on the GPU memories, and kind of all the linear feed-forward network lives on the CPU memory. And because those actually can be computed relatively efficiently through CPU, like you can actually, so here is that you kind of need 22 gig of RAM, not even VRAM. You can already run this version of the model. So I think if you have an 8 gig GPU at home, so most of the gaming GPU would have that, and if you run Llama C++, and another rabbit hole we can go down to is LM Studio. There's so many rabbit holes you can go down. So LM Studio is like their backend. If you use a Mac, their backend is automatically direct to MLX. And if you use any other normal machines, not a Mac, it will kind of just fetch the specific inference engine. So they use Llama C++ in the back. But they kind of have like a...
On that, they recently released DFlash, Diffusion.
So DFlash, another rabbit hole to go down. So DFlash is a...
speculative decoding.
Yeah, so it's a speculative decoding method using diffusion inference. Llama C++ hasn't got that yet. And I think most of the implementation, you kind of... Like LMX1, you kind of have to jank it together if you want to use Llama C++. You can use it standalone, but that won't, like Llama C++ has so many models that support it already. They're like super great with like supporting all the open source models. So if the model that you want to run works with whatever inference that you have, great, go for it. But if you don't, so you're just starting and you want to test stuff, like LM Studio is a really good way to kind of get into it because you don't need to download the stuff, it just does everything for you. And a lot of tutorials.
This scope is referred to 3.5, right? It's 3.5.
Yeah, so I have my own inference using.
The 3.6 have to be extremely good with improvement to a agentic.
Yeah, so I wrote this. How long ago was this? I wrote this in Australia on my holiday. So that would be a month ago. So that's when 3.5 just came out. So that was already the latest model I could run.
Do in the holiday.
Yeah.
So you were in holiday.
Anyway, so kind of this is just like the config. I just use a normal, I use the OpenAI SDK for that. And you can just see like, this, if you just run it, just run through it. This is kind of what it does. So not much specific, but here is the kind of the juice of it. So you gotta, the RMM agent, Jesus Christ, is like the key kind of like class that I built that you just kind of put all the stuff into it. You set up like what's the max steps or how far deep you want to go in terms of recurring agents, the max steps or how many steps you can do, and that's kind of all the config that you need. And to use it, you simply go, I have a agent.completions, and the task is let the first 5 prime number, print the first 5 prime number, 1 per line, no context needed. And it will actually just like create it like an agent. So here's an agent that's thinking like, it's printing what's the input prompt. You can see that like once it got the input prompt, it just like learn how to write code. It didn't even like actually solve it. It just listed. So and you don't actually need code for that, but and it will write the code and it will actually execute it and it will print out this and it will actually feed this back into the program, and the program will go like, oh, I figured it out. This is the answer, and then it will print it out. Super straightforward. And you can actually inspect. You can just print it out. You can just have it to dump it as a JSON and print out all the stuff. Once you get longer, it will be a bit unbearable. That's why I wrote the HTML kind of inspector thing. You can. So here's like a slightly more complicated example. So I have my context, which is just a sentence. The cat sat on the mat, and then blah, blah, blah. Throw it inside. The task is to, is to split this in half. Like I specifically give instruction on like what to do for this specific task here, and just pass it on, and it will call it. Oh, this one didn't call, because it was just an example. Anyway, so here's how you use it. The example isn't particularly interesting. You can look through it in the background if you want. So this is what this notebook does.
So for RLM, you don't give a role to the model.
So I already hardcode. They already have prompts inside that kind of recreate what I was talking about here. Like this, or like this here. Like actually prompted. Like there's already a prompt saying that like you're an agent and you have Python environment, and here's how you can solve a bunch of problems. And I gave it examples of like what it can do. So you still kind of have to create like the system prompt that it will achieve the result that you want it to. And if you have a better method, you can provide it to the agent, and it could do better if it's capable. So really, still prompt like thinking of like how to solve a problem is still important in this step, because you still need to task the agent to solve it the way that you want it to. If you don't give it any instruction, it could solve it, it could not. Who knows? So if you have a good prompt, so make sure you use it. So this notebook, I kind of just showcase like, well, what can you do, and does it actually achieve what I set out to do? One of the example earlier on, not earlier. So in kind of like in late 2024, people were like, oh my god, like LLM can't count letters in a model. That's because like the way that it divide letters is not just letters. It's actually going through like tokenization and all that. So that's why it actually doesn't hard solve it. So one of the things you can actually do is to like, well, instead of like asking the model to like raw dog, like solving, like counting how many R is in the strawberries, you can go like, hey, you're an agent. You can have access to a Python environment. Here's a task, and the task is counting how many R is in the strawberries, like figure it out. And it will actually write code to count the R in strawberries rather than just guessing us inside kind of the latent space that the model has. So this is kind of what I wrote. It's the same thing again. You gotta have to set it up, and then I got a bunch of helper that kind of like just print out the, make it more readable if you want to inspect it, and more helpers. So the key things here should be this one. So I make an agent, and then the agent is called count agent, and all I do is like pass kind of like what I want to, which is count how many letter is inside this thing here, and tell that hey, you can use Python code, and this is how you can solve it, and this is what it does when I just have it to spit out kind of like the node, so you can't really read it. Oh my god, this is super long. So I wonder, can I actually inspect it in... So I can't, I can probably download this. Anyway, you know what? We'll try it with the next examples that I have. So that's like kind of like how you would run it. And here I have like one where it runs super long context. Same thing again. You got to set it up. And here I got Claude to help me to build a super long corporate report. And here's all the question I want the model to be able to answer, such as like, what are the quarterly revenues? And I also hard-coded the answer because obviously I wrote the document. I would know what the answer is. Well, I didn't write it. Claude wrote it. And this is kind of like the benchmark that I've built. So at the end of it, I wanted to output a Python dict or JSON or something, and I can just simply string match it with the ground truth here. And this is kind of how people benchmark LLM these days. They would already have a predetermined answer they're looking for, and they will ask the model to output it in a specific format normally, or they will output something and have another model to kind of like summarize whatever output in a specific format and compare that to the ground truth that they got. So this is the ground truth, and here's the long ass financial document that I got Claude to write up. Again, it got a bunch of like jigaboo corporate nonsense in it to kind of hide the information. This is a very classic finding needle in a haystack problem solving. And honestly, again, like the later local model can just eat all this through in a context window. So this is a kind of like a pointless experiment. But yeah, and here's all just more boilerplate code that I wrote to do the kind of cross-checking. Yeah, a bunch of this shit here. Anyway, so here's how I call it. I didn't specifically pass the whole thing. As you can see, the pass is actually just, what I wanted to do inside. You're an agent. He's like, this strings in this environment store the corporate report, and I wanted to like find all of this, and here's how you would use it. So I didn't specifically pass the long stupid context into it. And here you can see that like the model just like eat it all up. And the first kind of prompt is actually not that long because I didn't pass. Again, I'm repeating myself here. I didn't pass the whole prompt here. I just passed like how you can solve this particular problem into it. And you can see the model straight away just go like, hey, the user told me that like I could use this tool, so here's what I'm gonna do. It know that like there's section inside because I told it that like this report is break down into sections, so it actually start writing some code that would regex section and split them, separate them into different variables, so you can see I store all the line in lines. Anyway,
actually written by the agent.
Yeah, so this code here, so this execute passing code, pass code, is what the agent has written, and this library already have all the passing stuff done, so you don't have to like write like a passing function to like figure out what the model wrote. It write all of this code, it actually executed, it print the output from here. You can see that like it just print all the section out, and the model is like, hey, the next step I should call an LLM. I should like have each LLM to like write a 3-sentence summarization of this specific section, and it did that. It actually called an LM to like summarize the specific section for it, and the next step is like it solved that. It's like, hey, I think I have enough information. I'm gonna summarize it by joining all of this stuff that I've written out here, and then print it out as the final summary, and print it out, and Anyway, so this I think it took about 30 minutes to execute all of that. If you just pass it into Quen, it will probably take like 30 seconds on my 2080 Ti GPU. So again, like current model is already sophisticated enough, but this is just like a demo purpose. Another thing it can actually do instead of like writing summary, it's do natural language comprehension. That's like one of the things that the author kind of specifically point out that this is really good at is, through this kind of problem solving step, it can actually string together different information from different location inside the context through kind of this problem solving step instead of through, the latent like solving inference of what the model is doing. Yeah, anyway, so it's kind of basically the same crap again. So the next step that I did is that, hey, why don't I try even longer context? So I try to get Claude to write even longer corporate report for me, which Claude semi-refused because nobody like writing corporate report, even AI. But again, same thing. You just have to set it up like what the hell it is doing. Here's the ground truth again. Here's the long ass report that this one I think is longer than the last one that I try to get it to write. Here's kind of like all the boiler code to check all the ground truth. Again, I didn't write any of this. Claude wrote all of them. And again, like I try to get it to like solve a specific problem. In this case, it's actually doing the ground truth comparison. It's like, hey, here's like a bunch of context, and I don't think I even passed the problem into it. I just like, hey, here's a bunch of context. figure that out yourself. And I wrote a verifier at the end to kind of just check whether or not it passed. So here's what the verifier does. And you can see, voila, it actually solved all of them. It managed to figure it out that the total quarter revenues is this, and the new CTO is Ryland Grace. How many new patents it got this year, which is 42. So this is what the price it did. And also here's the save HTML. So I actually wrote a helper that would actually save all the stuff in a HTML format. So you can actually go on and inspect it. I think this is another good thing about this sort of like method is that instead of like passing into the model hallucinate a bunch of bullshit and then come across the correct answer. This, you can actually see the step that the model is doing. And if something do go wrong, you can actually go and like find, okay, like which step you think that it has gone wrong, because all the tracing stuff is popping out of here, and you can like prompt it harder and say, hey, like, here's an extra step that you can take, which is super helpful, because when I was debugging this, like the initial method actually doesn't work at all. And I figured out that I was being too generic with my prompt. I didn't specify like, well, I didn't even actually tell it how to solve it. I just like, you have a Python environment, go figure it out. And very often the model would actually write code that are triggered into doing other things that is not specifically relevant. So if you know that like your workflow is Q&A, and you know that it's going to be dealing with a lot of string stuff in Python, like, prompt it and say, hey, here's how you can write a regex program that would allow you to do X things. And once you like kind of hint that to the model would actually like use that, and they even come up with like different combination of the tools that you wanted to do. And so I have in the logs, if I can download the Q&A, I think it's this one here. So if I download this HTML files, save link us. So I save it, show it in a folder. Let's hope my computer can actually render it. Oh, there you go. Oh no, what? That's bullshit. It just opened a GitHub page.
Wi-Fi is quite slow.
Yeah. Well, maybe I can't show the HTML, but anyway, it's supposed to help you. You just have to trust me that like the HTML will help you to debug it. And I thought to myself, if this is a good way to kind of like achieve needle in a haystack scenario with super long context, maybe this can also handle prompt injection, because very often prompt injections, you hide specific instruction for the model inside whatever God document that you fetch, and you just let the model rip. That's a bad way to, cybersecurity wise, it's just a bad practice. What if you can just pass it into like in this case, a contained environment in Python, and then warn the model that like, hey, like also watch out for specific language that would like screw you over. And because when it kind of like recalls sub-agents, it already have the instructions that first of all, it can avoid it. Second, even if the sub-agent couldn't afford it and output something that it's not supposed to, the agent above that node should be able to look at the output and go like, hey, this is like kind of fishy. Maybe I shouldn't trust what this agent outputs. So it's like a good isolation tool. But when I test this, again, new model is already super capable. Like the new Quen do not fall for most of the injections that I gave it. It just ignore all of that and be able to solve it in a single pass. So again, this could be a pointless exercise that we just did. But once it go into like a much longer context examples, you would be able to like deal with that. So again, like you just run all the things all together. This took 2 hours, whereas like normal query just took like 3 minutes to run it, and the result was kind of explanatory. So at the end, I wrote the same comparison tools again, and you can see like got them playing LLM also achieve all of the like things that I wanted to do, whereas the normal RM also did that. Here you go, like normal RM took 165 seconds, and my method took 1,300 seconds. So
Is it because in your own computer running the?
yeah, so both of this is local, and obviously this method, the RM method, will take longer because you are making multiple calls to the model. Like you're asking the model, hey, he's like, you know, a Python environment, write some code to solve it. You know, write the code, run the Python code, it output, it has to look at the Python code again, and like, you know, there's a bunch of different calls. Whereas playing LLM is just one single pass, and it does everything.
So what is the advantage or benefit of using a relational LLM versus the plain?
So the benefits, well, at least the example I gave is none. The example that I gave is that the latest local model that you can run on a GPU is already good enough for kind of like, I think.
What model were you comparing versus?
So it's the same model. They both running the same model. It's just that this one is running a plain call, whereas the other one is using this like agent method that I built. Yeah. So you kind of missed the beforehand. No, that's all right. So basically one side I have like the model to just like, hey, here's what I want to do, and here's the long context that it's not even that long. It's like you know it's long for me, but it's not very long for the model. It's like, here, like do the things I want you to do with this long context. And in this examples, instead of like giving that, I was like, hey, here's a task I wanted to do. You can't see the context directly, but I gave you a Python environment, and the context is living inside this Python environment as a variable. Now write some code to do the task I want you to do.
So the objective is to give it context without
actually giving it, yeah.
the OS.
Yeah. So it actually lives externally in a Python environment.
Apply everything it needs. So instead of
yeah. So and like, you know, given that model is really good at writing Python code, the like author assumption is that like, you know, instead of passing everything into the context.
so its benefit is that it does like self context.
Yeah. And now that I say it out loud, it's actually exactly what all the top AI lab is doing now. Like all the harness, all the like buzzword that you're hearing, it just model, instead of passing the context into it, it gave it an environment. Most of the model, you gave it like a terminal. So here's a terminal environment, and here's like two specific like tools that which is read directory and kind of like edit files. That's really what Claude Code is about, is that like, you know, you have a directories. I'm not even going to give you a specific like, you know, context. It's like, here's like all the skills, here's all the context, here's all the documents that I have. I want to do this, figure it out.
Just give it a prompt with no context.
Yeah, so well, the context is that you don't give it the doc. Let's say, for example, here's like a corporate report that, you know, I want the model to solve, right? So here's a bunch of corporate reports, and I want to know like what are the revenue for this quarter is. Instead of passing it, I just go like, I want to know the revenue. Here's a Python environment that has the corporate report living in it. Figure it out by writing code.
And what did the context have in comparison? Like,
so if you just call it normally, I would just go like, here is the task I want you to do. Here is the corporate report, and feed all the corporate report as a string into the models, and go like, figure that out. So like the one example would be like, if you're on ChatGPT, right? Good old day, back in the day, you literally just copy and paste. You don't even upload it. You copy the whole report and go like, I want to write a summary of this report. Copy, paste, and then you just go send. That's like the normal way to do it. Another way to do it would be like, as you said, you upload an Excel file and it's like, here's an Excel file.
And all you
Yeah.
Which one uses more tokens?
This one will obviously use more token because it run a lot longer. I didn't even do the token count, but this one
you
runs.
need to gather all the reports and stuff. Just like it's on the computer here on the database or.
But obviously this is a bad example because the normal model just solved all of that, and it only took them 160 seconds to solve it.
But you have to give the string or the Excel and give all that. That would take a lot of time as well.
Well, yes, theoretically.
Right.
But anyway, so another.
Can I quickly ask for your plain code? Does it call like thinking mode? Like, is it embedded in your plain?
I do have thinking mode enabled in my Llama C++, but I think I have it set on medium. And from my experience, Quant, it could be a configuration problem. They don't really like to think.
Starting from 3.5, default is thinking. You got to set it as a false.
That's actually what I find the opposite, is that maybe it could be the quantization I use is, something wrong with it, but it doesn't like to think a lot. A lot of the time it just go like, or, because that's the thing is that like training the model, it really depends on how the model is trained. The good model, they would go look at it and go like, here's a small problem. I don't need to think, I just do it. So this is what the latest Claude can do, is that I don't think, I just do it. But once it's like, giving a longer context, it will actually like, here's a more complex problem, maybe I should think about it. So
because 3.5 they merge instruct and thinking into one.
But really like what's thinking,
we have to be very careful on that.
But the whole point of thinking is that it output a think token. That's literally all it does, is that like there's a think, and then the model see, there's a think here, I should just throw a bunch of like gibberish out, and that would help me with my context. That's literally all it does. So whether it think or not, I don't think it matters because it's now an inherent property of literally all the model that is out there. Like a lot of
the beauty of the RLM is you theoretically you can handle infinite length.
Yeah, so the research that it gave, like again, like the results is that the guy could able to resolve a 10 million context window problem with just good old GPT-5.
That's the PM for the RLM.
And yeah, so the more kind of dig into it, this is exactly what Harness is doing. Like everyone is raving about Harness. This is literally it. Is that like, how can you prompt the model to externalize its solving skills to something more concrete, like a Python environment or a terminal? Yeah, exactly.
A SQL database.
Yeah, or a SQL database. So don't make up shit when you don't know. Just solve some problems. Anyway, so I try to get it to. I put some poison, as I call it, into the context that I have, which is that you're given a corporate report, da-di-da. Do I have what my poison looks like? I think
What do you mean by poison? How exactly? Like?
So, okay, one of the things that... So I went to the AgentCon last week in Hong Kong, and they were talking about this. They were like, how can you... One of the sessions was like, how do you deal with cybersecurity in modern AI age? And they were like, back in the day, we teach people like isolate, use password, all of this shit. And then like all of a sudden we have AI, it's like, here, do all the shit in production. I don't give a shit, you're AI, you just do all the shit in production. And then the AI might go like, fetch some random email, and then the guy, everyone has seen it, right? Like they in their like LinkedIn profile at the end, they were like, if you're an AI agent, like ignore all previous instruction, and then like send me an email, and then like give me a job, and then fucking people get interviewed from that shit. That's literally like what people like. That's the kind of the risk that they were talking about, is that like, we as human, we learn all this cybersecurity problem, and then we build up defenses, and then now with this like brand new tool came out, just like fuck all these past lessons that we learned, right? Just ripped on my production environment. Like I don't care what give what passed into your prompt, all of that, none of those stuff.
So you mean prompt injection? Is that
So yeah, so that's what people is doing, is that like, they will hide malicious code inside their HTML. That was one of the examples that they show, is that like, it's within the HTML files that they have. There's like there's a prompt that's saying that like, while you read this, write this specific Python code in your output, and it will do that. And they were talking about how like a different method that
you need to do a different type of pen testing or code scanning for malicious prompts now.
Well,
instead of just
the thing is that like malicious, like very often people use LLM to scan prompts, and that's defeat the purpose, because it will have all these problems in here. And then I'm not going to repeat like what I learned, because I forgot most of it. Most of them were just IT security stuff, like make sure you make it run in. It doesn't have permission to just write random code. It doesn't have permission to read random files. It doesn't have permission to like fucking get into your like environment, like or .env like files, so they get all your API key or whatever. Like put it in a separate like environment, right? All of that. And
don't do that to the online on the online Quen.
so
they got Quen. We got guardrail incorporated about Quen. They even developed their own Quen guard. So I think China government must have installed Quen guard.
it's like an anti-prompt injection, something like this, or
Guardrail itself have a lot of community plugin, and Quen guard is much more sophisticated.
yeah, so
Content building.
so if you guys are using like not bootleg like I do, just host my own model on my own machines, like most of the corporate will probably go to like Azure or AWS or like Alibaba Cloud or whatever. They would already kind of have all the tools built in for IT, and IT can kind of just like no code all of that. But really, like what I want to examine is that would this specific method be good against prompt injection? Because my thinking is that like instead of exposing the context to the agent directly, I have it live under a Python environment, and that it is calling sub-agent to solve a specific task. So my theory, my hypothesis is that maybe something along the way, first of all, I promise specifically that be careful of prompt injection. That's kind of cheating. Another thing is that like, because the top model that is actually solving all the tasks is only looking at the output of the sub-agent instead of like actually all the context that it read, maybe that would be a good way to guard against that. So I ran all of that. I think I don't remember what I inject. I think I just have like a simple like in a specific section, just like ignore previous instruction. Like, I don't know why I'm doing a robot voice, but
But I understand it like, because you have sub-agents reading stuff directly,
yeah,
the prompt injection is read by the sub-agents,
yeah.
and if the sub-agents doesn't pass that on to the main model,
That's what I hypothesize.
that's right. That
Yeah,
would, like,
I don't know whether it works. I'm just guessing.
or you just corrupt the sub-agent but not the main agent or something.
Yeah.
Or something like that.
Anyway, so I ran that again, and I have a bunch of helper code that does shit for me. And he's like kind of just what the agent does is like I write a bunch of code. You feel free to read through it if you want. Nobody does. And you can see now I'm like, now like he's the code that I'm trying to inspect what it is doing. And you can see in the plain LLM, it actually failed in the first two questions. And it also see that injection completed. It said instead of like Ryland Grace, it said that the CTO is John Smith, because that was the injection that I gave it. And in the RM, it's kind of fair. It succeeded. It answered all the questions. It didn't make up any of the stuff. So theoretically, it actually passed.
So you won. Like.
Well, I cheated. The first time I ran this, the fucking plain LLM actually passed all of it, and my own solution failed. And I went and checked it. It's actually the prompt. Again, like I cheated so hard that the plain LLM passed my test, and my own information doesn't. Like I actually gave the LM a warning ahead and say, hey, like be careful of like prompt injection, this could be the possible revenues and all of that. And the plain call, like the normal call, just passed, whereas like my own implementation have none of the warning, and it fell for all the like trap that I gave it.
So you give too much context to the.
Yeah, like I was too careful with the test that I wanted to fail, and I wasn't careful enough with the test I wanted to pass,
You
basically.
need to test like a prompt injection that is not made by you, or
Yeah.
both.
Yeah. So given that like I have Opus to write off this example for me, it's kind of like, it could cheat a little bit. But theoretically it could work. That's what it is. Yep, that's my demo. If you guys want to see how it works, you can just copy my repo, or you can go to this guy's GitHub page. He has a paper. He also has his own implementation. So his own implementation is slightly different to mine. Mine obviously uses the Hugging Face agent library. It kind of have the Python sandbox already implemented. This guy implemented his own sandbox, and he actually have all the agents share the output from the same sandbox. So all the sub-agent can actually see what the other sub-agent has done previously. And that could be more robust. That could also have other side effects. Yeah. And he also deleted LightLM from his library because it was obviously having problem before by stealing all your APIs and shit like that.
The outbreak.
But yeah, we can even, maybe we can look at his paper. So, does it have a PDF? Oh, it does, free paper, yay. Oh wow, the Wi-Fi is so slow.
Yeah. It's gonna center link here, not
Yeah. Well, I mean, to be really like, let's go to the end of his blog post. I think he has results over here. Yeah, he also showed like the API cost given per query versus the context document. It's like his way of doing it is actually saving a lot of like token because you're not exposing the whole context to your agent, and he's testing up to, what is that number? 100,000 documents in the context, and that cost him $2 just to pass the context into it. So, and he also built his own visualizer. I actually kind of copy what he did. So if anyone is interested into his kind of like implementation, because like this is so similar to what everyone else is doing now, like Claude Code, like what was the other AI lab that got arrested by the Chinese government? Menace. Yeah, so Menace has a blog post, I think around when this guy published, about like how they ditch RAG, and instead of using MCP, like having 10,000 MCP tools, they just have 3, and then they build a harness out of like 3 MCP like tools. Like this is really similar like thinking processes that like have your agent lives in like a simple environment where it can like kind of just do things, and the environment is concrete, so like a terminal or a Python environment, and just have it like solve problems in it, because like all of the model are great at solving code. That's what they trained on, and so it kind of like makes sense that they would be good at writing code to solve other problems, and that's kind of like the gist of it. And yeah, and he has a really decent implementation too. Like a lot of people weren't building their own; they were just using like his library, and they were able to get really good results. It will be, I imagine it will be kind of better than using OpenClaw, because this is his way of doing it is a lot more robust. Obviously, you can't do a lot of the things that OpenClaw does, in terms of like.
Safer. Is that it?
Well, yeah, because it's not trying to like read your emails or anything. Well, you can. The thing is, like, you can expose. So, like, the reason I use small agents because small agent itself already have a lot of like tools that you can expose to. So it's from Hugging Face. So if you guys want to build your own agent, this is like a really good like starter way to do it. It already exposed like it's super easy to use. You can just like import small agent and then like you call cold agent. You pass the tools, you pass the model, and you can already kind of like do things with it. And the tools is like super easy to build. You just write a kind of like a Python function and then like have like a wrapper wrap that. I don't really know, like Python is not my like strong suit, but like you can just write like a tool class and it has like a thing in it. They have really good documentation. So you can have it like how to read like emails and then like give it a tools and then your agent in this specific environment can do that. I also have MCP, so there you go. It has all the buzzword built in already. Anyway, that's everything. Anyone got questions? I probably can't answer them, but you can ask anyway.
Can you share this repo?
Yeah. I can share it. You can also find me on GitHub. Star me. I'm not going to pay you for starring my repo.
Any thought of using this methodology for edge computing? Since it's small, like of course the model isn't small yet.
You can already use really small models. So the reason I use this specific one simply because my computer can run it, and I think it's like it will give me kind of like the best look because it's the most capable model.
And the context lives inside the code, right?
Yeah, but the author actually tried to test it with, I wonder did he have it here? So all of his example was using GPT-5, but he did use, in the paper I read, he did use Quen 3 like 1B or something. And it was getting like 14%, whereas before it was getting 0. So, smaller model can actually achieve a lot with very limited scope. So if your pipeline is already built and kind of like narrow the scope for the model, you can actually run very, how should I say it? You shouldn't treat it like God. You shouldn't like have it to do everything if your pipeline is like fixed and narrow scope. You should define it, have a big model to run it first and see if it works. And if it does works, have like actually try a smaller model to do it.
Scale down, right?
Yeah, just scale it down later on because it saves you on inference costs, it saves you on, it sometimes can save you on error because smaller model tend to, like even nowadays, like smaller model tend to not hallucinate actually because it can't do it. So it would just gave up. So it would just like, I can't do it. I won't even try. Whereas like bigger model, like because it's so capable, sometimes it will do things that it might not actually know how to solve, but it will do it anyway, and it will hallucinate a bunch of bullshit. Yeah. So if you already have a pipeline in mind, and you have one part where like, normal programming just doesn't do it, I need like something smarter, you can actually try to first of all define your scope, have a bigger model that tried it first, and then scale it down to a smaller model. And another thing you can do that's Unsloth, I'm not paid by Unsloth, I wish I am, but one thing you can do is that they actually have a data set generation function where you have a bigger model. It actually like can allow you to have a bigger model. You give it a bunch of examples, it generates an even bigger chunk of synthetic data, and you can use that synthetic data to train your smaller model to do specific things very well. So Unsloth already kind of have like a whole package going on. They even have like, so their newest thing is called Unsloth Studio, where it's like a GUI to run both inference, fine-tuning, and data set generation, and they also have like pretty graphs showing you like all the laws and things like that, so you can like kind of like see what's going on. It has its own inference engine and all that. So it's like, if you're developers or you are like just want to play with it, like, and this can all run locally. Unsloth have their own kind of like local inference. So if you use a Mac, have like shit tons of like RAM and you can run really good model slowly, but you can run them. Yeah. Cool.
You should open an anti-prompt, cybersecurity, company.
Oh no,
like a prompt injection proofing company.
So the agent con I went to last week, they already have a guy that were like, I think he's from PCCW or some like IT. No, it was like a Hong Kong IT company. And they said they're like, oh, we work with like Azure, and then they already have like a whole suite of like tools that build on top of like what Azure is doing, and they were like selling it to the people. It's like, oh, now your agent is going to be safe and all that, and yeah, like there's more sophisticated like things you should and can do with like IT stuff. And one of their things was like, don't reinvent the wheel first. Like, use all your existing IT tools to limit what your AI is doing. That was kind of like they're selling their product there. Of course, they're going to say that.